Hello children, welcome to your online physics class. In the previous lecture I discussed about Newton's law of gravitation. Today I am going to discuss about gravity. Okay, so let us start with gravity. At first you have to understand the difference between gravity and gravitation. Actually gravitation is the force between two bodies due to interaction of their masses, and gravitational force is the force acting between two bodies due to their masses. Gravity is a special case of gravitational force. In this case, if you have two bodies and one of them is very heavier than the other, okay, one of them is very heavier than the other, then the gravitational force of attraction applied by the heavier body to the lighter one is called gravity. As we people reside on the surface of the earth, so earth is supposed to be the heavier body, heaviest one for all those bodies which are under the gravity of the earth. Okay, so in general we talk gravity in the sense of the gravitational force applied by the earth on a body. Okay, so here you have to learn in class 9, you just have to understand that gravity is the gravitational force of attraction applied by the earth to a body. Got it? This is also called weight of the body, because you learnt weight of the body is the gravitational force, gravitational pull with which earth attracts it towards the center. Got it? So gravity is somehow same as that of the weight of a body. Okay, so here I am discussing about the expression for gravity. Suppose this is a body, its mass is m, and this is earth. This is earth. Mass of the earth is concentrated at its center. Suppose this is capital M, and the distance between the two bodies is r. You see, size of the body under consideration is very small in comparison to the size of the earth. So its size will not be taken care in order to find the distance between the center of the earth and the body. Okay, so this earth will apply a gravitational pull on this body. This is called F. As a reaction, this body will also apply a gravitational pull on the earth in upward direction. That will also be equal to this F. Okay, but this force which is applied by the earth on this smaller body is called force due to gravity or simply gravity. Got it? I think it is clear to you. I think you have understood the meaning of gravity. Again I repeat it, gravity is the gravitational force of attraction applied by the earth to a body around it. Got it? Okay, so this is Fg. Now you know, whenever there is a force on a body, that is, if a body experiences a force, there must be an acceleration, because you know acceleration is caused by the force. You also learnt acceleration as the effect of the force. Okay, so if a force will act on a body, the body will experience, the body will have an acceleration. Okay, and if the force causing the acceleration in the body is gravity, then the acceleration is said to be acceleration due to gravity. So let us introduce the topic acceleration due to gravity here. Acceleration due to gravity. Okay, in simple language you can write it is the acceleration caused by earth's gravity. Okay, it is the acceleration caused in a body due to earth's gravity. Whatever language you want, you can write these facts in your own words. Okay, so this is the acceleration due to gravity. Now if you got the definition of acceleration due to gravity, you must find the expression, you must find the formula for acceleration due to gravity. You see, how can you find the formula? So acceleration due to gravity on the surface of the earth is denoted by small g. Okay, and you know g is equal to force by mass. So acceleration due to gravity, g is equal to force by mass. Okay, this force is gravitational force of attraction, and you know formula for gravitational force of attraction from Newton's law of gravitation. It is F is equal to g m1 m2 by r squared. Okay, so if you will use this formula here, what will you write? F g m1, m1 means this m, mass of the earth, m, m2 means mass of the body, that is small m, by distance, this is r, r squared upon small m. So these 2m will be cancelled out, and ultimately you will have g m by r squared. This is the expression for acceleration due to gravity on the surface of the earth. You can see that this small g is independent of mass of the body, because mass of the body is small m, and here we have capital M, which is constant for this. This is the mass of the earth. So whatever this body will have the mass, that will not affect the mass of the earth, that is m will remain same, capital M will remain same. This capital R will also remain same because it is radius of the earth, and capital G, you already learnt that this is universal gravitational constant, so it will never change. Okay, so the value of G will be constant in general, means it will remain same, acting on all the bodies on the surface of the earth. Although I will discuss about variation in G, means the factors which can affect small g, in next lecture. But here you just have to understand that for every body, acceleration due to gravity will remain same. Is it clear? Now you can think what will be its value, the value of G. You see, capital G is equal to 6.67 into 10 power minus 11 Newton meter square per kg square. You already know. M means mass of the earth, it is 6 into 10 power 24 kg, and R, radius of the earth, this is 6.4 into 10 power 6 meter. So if you will substitute all these values, this G will be equivalent to 9.8 meter per second squared. So value of a small g is 9.8 meter per second squared. If you want to change it into CGS, it will be 980 centimeter per second squared, and in FPS this is 32 feet per second squared. So these are the values of acceleration due to gravity in normal condition. Is it clear? Now see, in some questions you can use G is equal to 10 meter per second squared. Okay, means if you have a long calculation, then you can take approximate value of G as 10 meter per second squared in place of 9.8 meter per second squared. Got it? Okay, but it should be clearly remembered that G is 9.8 meter per second squared, and you have to take G 9.8 meter per second squared in normal cases. Only in specific cases, whenever it will be lengthy calculation, then you can use G is equal to 10 meter per second squared. Sometimes it is written in question that take G is equal to 10 meter per second squared. In that situation, you can take G is equal to 10 meter per second squared. Okay, hope you understand acceleration due to gravity. Thank you.